Okay, that sounds good. However, sometimes we don't actually know the numbers of items to insert in advance. That's usually uh, just just happen dynamically when the program is running. Is there how can we deal with that situation? The solution is called dynamic memory allocation. That means we can assign space for data dynamically. Um, so in this case, what we have to do is we have to be familiar with is function one m lock. So this is for create or allocate a memory space with the number of specified bytes. Here's one example. Here we are actually allocate memory with 10 bytes. So, and we can convert, we can use that space for store uh, the string, the char array in that case. And another function you have to remember is the fray. After the allocation of the memory space, you have to remember this. This is pretty important to free that space. Otherwise, it will cause a leak of the memory space. It's quite important to use them as pairs. And also, it will here is a tool function called size off, which will help you to uh, decide or determine the size of that space, because it's actually will tell you um, um, uh, how many bytes of each of the data type takes. For example, here will give you how many bytes int takes in here, and this code is gonna give you how many bytes a char takes. In that case, you don't have to give it by yourself, and because as we mentioned previously, in different machines, this number varies. So here, by using this code, the program will decide it by itself, because its read will give you the information that how many bytes they take. So, but to use those functions, you have to include the header file stdlib.h. So, okay, here's the code for do that. For doing that, here you can see at the very beginning we have allocated our space with malloc 100 bytes, and we're using at the very beginning we're using that space as a char for char array, and that means we can use that for strings. Here we are using strcpy to copy a string into that space. So after that, we're using this function to bring out the values of each of the byte in that space. Here you could see at the string as here. We could use the printf to print that string out dynamic space. Because if you're checking out the value of that in that space, you could see A is actually here. If you remember the value of the ASCII table, you will recall that the value of A is 65. Okay, and here is a space. The value of the space is 32. So and so on and so forth. You could see that we actually have setting the values of the space we just allocated. Okay. The second part of that program is that we're trying to use the same space to store an int array. So in that case, because the int array is kind of different from the char array, because the char array, for each of the char it takes 1 byte. However, for each of the int, it takes a different number. Usually it's 4. So, but we're not sure. We're not gonna take input of 4. Otherwise, the size of the int will be hard coded into the program. In case that in the target machine it's not 4, this will cause problems. So we're using a size of to give that number. In that case, if it's 4, the size of that array will be 25. So because we have 100 bytes allocated previously. So in that case, here we can set the value of the int array one by one using this loop. And in that case, we're setting them from 0 to usually is 25. So, and then we are printing out that value. You could see from here, we actually, in my machine, int takes 4 bytes. So here is the first 4 bytes. Here is an int. Here is the second int. First one is 0 because we're setting them with this loop. And the second is 1, second 4 bytes, and 2 and 3 and so on, so forth. The value have been set successfully, and we are using the same space for saving the values of the ints. Okay, as I mentioned previously, you have to make sure you're using these two functions and pairs, because every time you have assigned a space dynamically, you should remember to free them. Otherwise, it will cause leak of the memory. So